Differentiation, Part 3. In the previous chapter, we have already discussed how to use the first principle to find the derivative of a function. However, if I give you a complicated function, maybe it is quite difficult to use the first principle to find the derivative of a function. So, we develop several theorems to find the derivative more easier. For example, the first theorem is called power rule. This is power rule. If we have a function f of x, which is equal to x to the power n, where n is a positive integer, what is the values of the derivative of these functions? F dash x is n times x to the power n minus 1. Okay, so give you one example. What is the derivative of x to the power 4, which is equal to 4 times x to the power 4 minus 1. Maybe you can remember, okay, we can write down the power first, and then the power need to decrease by 1. So which is equal to 4 times x to the power 3. This is the first theorem you need to remember. We will call this as power rule. The second one is how to find the derivative of c times a function where c is a constant. We can take out c from the derivative first. That means find the derivative of a function and times c after finding the derivative. So let's see some example. Example 4.5. So y dash, part A, y dash. Because 7 is a constant, so we can take it out and find the derivative of dx of a function of x. So this is x to the power 1. So according to the power rule, we can write down 1 and the degree minus 1. So it's 7 times x to the power 0 is equal to 7. Let's see one more example. I want to do part D, and then you can go home and try to do part B and part C. The function is y is equal to 6 times square root of x. Normally, I will change square root of x to the power 1 over 2. So y dash is equal to, we can ignore 6 and find the derivative of x to the power 1 over 2. So write down the degree first, and degree minus 1 is equal to 3 times x to the power negative 1 over 2. You may do part B and part C. We can check the answer during our lesson. Let's see one more properties, one more theorem. If we have two functions, for example, one is f of x, another is g of x. If we want to find the derivative of the addition or subtraction of these two functions, we can find it separately and then add them together or subtract them together. So what is the use of this property, this theorem? Just like example 4.6. We have already discussed how to find the derivative of this term and this term. So next time, what can we do? What is the values of y dash? You can take out 7 first and then find the derivative of x and then plus. Because we can make good use of the above theorem, we can find the derivative separately. This is x to the power 1 over 2. So write down the degree and degree minus 1. This one is x to the power 0, so it's equal to 1 plus 2 times 1 over 2, x to the power negative 1 over 2. And then the answer is 7 plus x to the power negative 1 over 2. How about C? We have 1, 2, 3, 4, 5 functions. If we want to find the derivative of this 5 function, We can do it separately and then add them or subtract them together. So for the first one is 4. According to the power rule, we can write down the power and power decrease by 1, so it's 6. And then 12 times 5 times x to the power 4 minus 14 times 2 times x to the power 1 plus 7 times x to the power 0 is 1. How about negative 5? Minus d over dx. This is 5 times x to the power 0. So we can write down the power. So 0 times something must be equal to 0. So remember, next time if you want to find the derivative of a constant, okay, independent of x, this is equal to 0. So which is equal to 28 times x to the power 6 plus 60 times x to the power 4 minus 28x plus 7. You can do part B and part D, and we can check the answer during our lesson. And for exercise 5, last theorem I want to discuss, which is called product rule. And we have already discussed that how to handle the two functions. If they add them together or subtract them together, we can find separately. How about if they multiply them together? What can we do? If you want to know why d over dx u times v is equal to u d over dx v plus v du over dx, you can refer to the following proof. So next time you need to know, if I want to find the product of two functions, you can write down the first function and find the derivative of the second function, plus write down the second function and find the derivative of the first functions. Let's see the example below. Okay, example 4.7. If y is equal to x to the power 3 minus 4x times 2x squared plus 3. In this question, maybe you can expand and simplify first, and you can find the derivative by using the expansion. But I want to demonstrate how to use the product rule. Y dash. We can write down the first part of a function, because the relation between them is multiplication, so write down the first one and find the derivative of the second term. If you are familiar with the derivative, you can write down the answer. This is equal to 4x and plus 0. And then plus, write down the second term, and this is 3x squared minus 4. Because we can write down degree and degree minus 1, and this is negative 4x. After finding the derivative, this term is equal to 4. So, which is equal to 4x to the power 4 minus 16x squared, and then plus 6x to the power 4 and minus 8 plus 9 is plus x squared minus 12. So the final answer is 10x to the power 4 minus 15x squared minus 12. So you can also apply the product rule to do for exercise 6. Try to do it and let's check during our lesson.